So if these two things are equal, that means several things. So first of all, F net equals MA. That's always the setup equation you want. So this equation, F net is always up forces added together minus down forces added together. So the up force is only FB. The down force is only FG. It doesn't say there's an acceleration, so MA is 0. So you would add FG to the other side, and you get this. FB equals FG. So B says, find the mass of the displaced fluid, the amount of oil pushed out of the way by the French fry. Hint, you already know the density of the oil and the volume of the oil displaced. So it says the fry displaces this much oil, and it says the density of the oil is that. And so if I want to figure out how much mass is pushed out of the way, I'm just using the density equation. Right? If your boat floats in the water, and you know how much volume the boat pushes out of the way, you know the density of the water, you can solve for how much mass that is that it's supporting. How much mass is being pushed out of the way. Okay? That's what you're doing here. So this is the density of the fluid, the oil. This is the volume of the fluid that's pushed out of the way, which again, the problem says that specifically. It pushes that much oil out of the way. So you would plug that in and solve for the mass, and the answer to C is the answer to B. Because if an object floats, the masses are always equal. Always. If the object floats, the masses and the volumes are equal. 100% of the time, every time. Okay? So when you're doing the boat lab, if you want half of your boat to float, you want your boat to float halfway in the water. Estimate the volume of your boat, cut that in half. That's the volume of water pushed out of the way. Figure out the density of water. It's 1,000. Solve for the mass. That will tell you how much mass your boat's able to hold. Now, that's going to include the boat's mass also. So you will need to subtract the boat's mass out to figure out how much mass you can have. But that's the idea. Okay? If you want your boat to just barely float, then you would pick a volume equal to the volume of your boat. Again, density of water, solve for the mass. All right, and that's 3. That's all there is to 3. All right, let's look at 4. So a 9-kilogram block of botrydinium is accelerating up through the ocean at a rate of 0.05 meters per second squared. What is the density of this incredible new element that makes you smarter just by being around it? So the first thing you want to do is draw a diagram, label the forces, set up Newton's second law. All the time, every time, all the problems. So here is my water. Here's my object. It's going up through the water. So there are only 2 forces on it. Buoyancy up, because it doesn't say there's a lift force. There's not a push force. It's just buoyancy up, gravity down. And then there's an acceleration up. I'm going to draw the acceleration off to the side because it's not a force, but it's accelerating up. So, draw the diagram. Done. Label the forces. Done. Set up Newton's second law. All right, F net equals ma. F net is all the up forces. Buoyancy, that's it. Minus all the down forces. Fg, that's it. Equals ma. This time it's not 0 because I say it accelerates at a rate of 0.05. So ma is an actual thing this time. So B, use Newton's second law to solve for the buoyant force. I don't know what Fb is, so I just write Fb. Minus Fg, which the equation for Fg is mg, mass times 9.8. So the mass is 9 times 9.8. equals ma. Mass is m, it's 9. A is the acceleration, it's 0.05. You will use this equation to solve for the buoyant force. Once you've done that, then you're ready for C. Use one of your buoyant force equations to solve for the density of the object. This is the buoyant force equation you're usually going to use. So you would just set that up. Buoyant force equals density of the fluid times mass of the object over density of the object times g.